Hi, welcome back to my statistics class. So today we're going to introduce the normal distribution. So what is normal distribution? In the previous class, we talked about binomial models, which is a discrete probability, and normal distribution is a continuous probabilities. So what is continuous probability? What is discrete probability? So let's do some reminder. So review. So continual discrete probability means that you measure by counting, such as 1, 2, 3, 4, 5. That's your variable by counting. But continual probability is by measure, such as the height, your weight, the time that you use to commute, the volume, and so on. So these are normal distribution. These are continuous probability. So normal distribution is a type of a continuous probability. So this is called also called Gaussian's distribution, and the shape is going to look like a bell curve. So this is also called a bell curve distribution. So the normal distribution describe the tendency for the data to cluster around the central value. In fact, the central value is the population mean, which is always located in the middle of the curve. And most of the data near the mean. Most of the data is located near the mean. And the standard deviation sigma is characterized how spread most of the data is. Okay, now here's an example. The mean annual rainfall in Portland is unimodal and approximately symmetric, with a mean of 40 inches and standard deviation of 8 inches. Rounded to the nearest inches, enable the normal distribution model for this situation. So in this case, we know that, hey, in the center, this is going to be the mean, okay? So the mean, this is the notation, mu and the sigma, where x is the variable and n stands for normal distribution. Mu is the population mean, which is the average value. Sigma is the standard deviation. Okay, so we have the probability model of a normal distribution with a mean 40 and the sigma 8 inches. So what's that mean? That means in the center of this distribution, this is 14 inches. And then when you add one standard deviation, which is 8, here is your one standard deviation. You add 8. So the next standard deviation is you add another 8. So I add 8, and then I add another 8. This is called 2 standard deviation, which is 56. And then in here, the third standard deviation, you add 8 from the second standard deviation. So I have 64. So to the left, we subtract 8. So we have 32. And then we subtract another 8. We have 24. And we subtract another 8. We will have 16. So as you can see, when it comes to the center, that's the average, which is most of the data is most likely to happen. So that's why the curve is tall, and at the two end, which is you either be really drought or it's going to be flooding. I don't know if that considered flood or loss of rain, extremely loss of rain, which is really less likely to happen. So that's why the curve is going down. Okay. So now let's talk about, there's a really important things about normal distribution is called Imperial Rule, which is 68, 19.5, 99.7 rule. In the normal model, about 68% of the value falls within 1 standard deviation of the mean, which means this area takes 68% of the total area. That's 1 standard deviation, plus or minus 1 standard deviation, right? And then about 95% within 2 standard deviation. So this part is 2 standard deviation, which takes up 95%. And then 99.7% falls within 3 standard deviation of the mean. So where's this 3? Oh, it didn't label here. Let's assume it's in here. So that means the data is going to fall to here. It's going to be 99.7%. So this is called Imperial Rule. Label, okay. So a value that is more than 2 standard deviation away from the mean is considered unusual or an outlier. A value that is more than 3 standard deviation away from the mean is very rare. So in normal distribution, we will consider that, if you're outside of 2 standard deviation, which is this part, we will consider this is an outlier or unusual data. Okay, so now let's use our GeoGebra. So here, they say to find the percentage of the normal model, draw and label the model shade area of percentage that you want to find. In this case, our mean and annual rainfall in Portland is 14 inches with standard deviation of 8 inches. So what percentage of the time is usually the rainfalls between 13.2 and 48? So now let's label it. So we know that the center, which is the mean, is going to be 14 inches. And then 1 standard deviation means we need to add A, which we have 48. And then we subtract 8, we got 13.2. So within this area, we call it with 1 standard deviation. So in this area, we labeled this part. So this part is what? So since it's within 1 standard deviation, by the Imperial Rule, we know that the probability that x between 13.2 and the 48 is going to be 68%. Okay, so what's the probability that an annual rainfall is more than 48 inches? Okay, so how do we calculate that? So we know that this is 40, this is 48, and this is 13.2. So they want you to calculate the probability of this part. So remember that a normal distribution is symmetric. That means this area is going to equals to this area. Okay? So we know that the total area is equals to 1. And we know that within 1 standard deviation, this part equals to what? This part equals to 68. And the total equals to 100. That means the area, let me change the color. The probability of x greater than 48 plus the probability when x less than 13.2 equals to the total area, which is 100, subtract the pink part, which is within 1 standard deviation, which is 68%. So this is equals to 13.2%, right? But we're not done. 32% including two parts. The part that greater than 1 standard deviation and the part that less than 1 standard deviation. So when we divide it by 2, since they're symmetric, these two areas should be equal. So when we divide it by 2, we will have the probability that the annual rainfall is more than 48 inches. So that we use the symmetric characteristic of a normal distribution to calculate this one. So what percentage of the time is an annual rainfall 24 inches or less? So now let's label it. So we know that the mean is 40 and 1 standard deviation is 48, 2 standard deviation is 56, and then less than 1 standard deviation is 32, less than 2 standard deviation is 24. Okay, and then we know that within 2 standard deviation, also the green part is what? By the Imperial Rule. This part is 95%, right? And we use the symmetric characteristic. We know that these two n, the two blue shaded area are the same, but we're just trying to calculate the left tail. So that means if we can calculate the total of the blue shaded area, we divide it by 2, we will get the probability that the rainfall is less than 24 inches. So pause the video and try to calculate that by yourself. Okay, I hope you will get the answer. So the probability, we know that these two parts, which is when the rainfall less than 24 inches and the rainfall greater than 56 inches are the same. They are going to equal to 100% minus 95%, which is 5%. And then since they're symmetric, we know that the rainfall less than 24 inches equals to 5% divided by 2, which is 2.5%. Okay, what's the probability that the annual rainfall is 54 inches or less? $54 inches less. Okay, so I think this one meant to tell you that 56 inches, which is within our 2 standard deviation. So let's change it to 56. So how to calculate that? Pause it and think about it by yourself. Remember to use the symmetric. Okay, so we know that this is 40, 48, 56, 32, 24. They want you to know that less than these parts. So again, we can use, if we can find out this part, the pink shade part, we use 100 to subtract the pink shade part. Then we will figure out what will be the blue part. So from the previous questions, we know that, hey, when P, which is the rainfall less than 24, should also equals to when the rainfall is greater than 56, which is 2.5%. Okay, so that means this part is 2.5%. So that means the blue shady part, which is the rainfall less than or equals to 56 inches, should equals to 100% minus 2.4, which is 97.5. 97.5, which is really likely to happen. Okay, so that's it today. Next time we'll talk about how to use GeoGebra to calculate our normal distribution. See you next time.